Hello everyone and welcome back to Math 143, Finite Mathematics. In our previous lecture, we studied annuities. We learned how to find the future value of regular deposits and the present value of regular payments. Today, we are going to reverse those annuity formulas. Instead of finding the value of an annuity, we will determine the size of the regular payment requirement. We will study two important applications. The first one is loan amortization and the second one is sinking funds. Okay, by the end of today's lecture, you should be able to explain the meaning of loan amortization, calculate the periodic payment requirement to repay a loan, explain the meaning of a sinking funds, calculate the regular deposit requirement to reach a savings goal, and distinguish between amortization and sinking fund problems. Okay, before we begin, let's briefly review the main idea from the previous section. Okay, an annuity is a sequence of equal payments made at regular intervals. For the present value of an ordinary annuity, we use the formula right. For the present value of an ordinary annuity, we use the formula R times 1 minus 1 plus I to the power negative n over I. Also, for the future value of an ordinary annuity, we used the formula future value R times 1 plus I to the power n minus 1 over I. In today's problems, we already know the present value and future value, and our goal is to solve for the payment R. Today, goal is solve for the payment R. Okay, then let's begin with loan amortization. Loan amortization. Right? So, when a person borrows money, the loan is usually repaid through equal periodic payments. For an example, payment may be made monthly, quarterly, or annually. Each payment contains two parts. There are two payment parts. The first one is interest charged on the unpaid balance and repayment of part of the principal. As payments are made, the loan balance gradually decreases. When the final payment is made, the balance becomes zero. This process is called amortization. Okay, let's go through the process. First, when we borrow money, okay, when we borrow money, the loan is usually repaid through equal borrows money, right? Usually repaid through equal periodic payments. For an example, payments may be made monthly, quarterly, or annually, right? So each payment contains two parts. The first one is interest charged on the unpaid balance. Second, the repayment of part of the principal. So as payments are made, the loan balance gradually decreases. So then, as payments are made, the loan balance gradually decreases, right? Gradually decreases. So when the final payment is made, the loan balance becomes zero. This process is called amortization, right? Then the payment required to amortize a loan, we have a formula that means, okay, let's see. Formula, that means the payment required to amortize a loan is R equals I times the present values 1 minus 1 plus I to the power negative n. So its symbol here R is the payment made each period. PV, the amount borrowed. I, interest rate per payment period. That is R over M, annual interest rate over number of compounding period. N, the total number of payments. So let's say N equals M times T, T in years. Okay. So before substituting into the formula, always calculate I and N using I equals R over M. If the annual interest rate is R compounded M times per year, then I equals R over M. And N equals M times T, the payment schedule must match the compounding schedule. For an example, monthly payments and monthly compounding use M equals 12, quarterly payments and quarterly compounding use M equals 4. Because we discussed these parts in our previous sections. Okay, then let's move forward. Example 1. Let's say quarterly loan payments. A loan of $100,000 is repaid over 10 years through equal quarterly payments. The interest rate is 3.6% per year, compounded quarterly. Find the quarterly payment. Okay, let's solve this problem in step by step. First, identify the present value. Step 1, identify the present value. So, the present value is 100,000 because the amount of borrowed, the loan of $100,000. Therefore, the present value is 100,000. Then step 2, find the periodic interest rate. So it says 10 years repaid over 10 years through equal quarterly payments and the annual interest rate 3.6. Then step 2, find the periodic interest rate, that is the annual rate is 3.6. That means R 0.036. Since interest is compounded quarterly, M equals 4. Therefore, I equals R over M, 0.036 over 4, 0.009. The interest rate per quarter. Okay, then let's move forward. Find the number of payments. Step 3, find the number of payments. There are 4 quarters per year. That means there are 4 quarterly payments each year for 10 years. There are 4 quarterly payments each year for 10 years. Therefore, n equals m times t 4 times 10, 40. 40. Okay, now we have all the details. Then let's substitute into the formula. Step 4. Substitute into the formula. R equals I times PV over 1 minus 1 plus I to the power negative n. Okay, let's substitute then. R I equals 0.009, PV 100,000, 1 minus 1 plus I 0.009 negative 40. And then let's calculate first the numerator. Let's simplify the numerator first, right? 0.009 times 100,000 that is 900. Then therefore R becomes 900 over 1 minus 1.009 negative power 40. Okay, then for the denominator, denominator 1 minus 1.009 to the power negative 40. 1 minus, you can use your calculator to get the values. How much the value is. Use your calculator to get the value. Zero 0.6988, then 0.301112. Okay, then using calculator again, R equals 900 over 0.3012. 900 over 0.3012, 2,988 and 04 cents are. So the required quarterly payment is 2,988 and 04 cents. $2,988.04. So the required quarterly payment is 2,988 and 04 cents. Okay. So This means the borrower must pay approximately $2,988.4 at the end of every quarter for 10 years. Then how many total payments will be made? There are 40 payment periods. The total amount paid is approximately 40 times the amount 2,988 and 04 cents. Let's see the interpretation. Okay. Okay. So here this means the borrower must pay approximately 2,988 and 04 cents at the end of every quarter for 10 years. Then how many total payments will be made? There are 40 total payments. Then the total amount paid is 40 times 2,988 and 04 cents. That is 2,988 4 cents times 40. 119,521. So the difference between the total payments and the original loan is the approximate interest the borrower paid. So the difference between the total payments and the original loan is the approximate interest paid. That is how much that the borrower paid interest? 19,521 and 60 cents. Right? Okay. I will give you the exercise. Please pause the video and do it by yourself. The exercise: a loan of $50,000 is repaid over 5 years through equal monthly payments. The annual interest rate is 4.8% compounded monthly. Then find the monthly payment. Okay, pause the video and identify the present value. I, that means the periodic interest rate. N, the total number of payments before counting the monthly payment value. R. Okay, pause the video and take your time to get the answer. Step 1. Check the values. Okay. In an amortization problem, we begin with money that has already been borrowed and gradually repaid. A sinking fund works in the opposite direction. Instead of reducing a debt to zero, we make regular deposits so that an account grows to a desired future amount. Right? Okay, the note. In an amortization problem, we begin with money that has already been borrowed and gradually repaid. A sinking fund works in the opposite direction. That is, instead of reducing a debt to zero, we make regular deposits so that an account grows to desired future amount. Okay, a sinking fund is an account into which equal deposits are made regularly to reach a future financial goal. Let's make the definition of the sinking funds. So a sinking fund is an account into which equal deposits are made regularly to reach a future financial goals. For an examples, there are so many common examples: retirement savings, college funds, saving for a house, replacing equipment, or preparing for a large future purchase. So in this type of problems, that means the desired future amount is known and we solve for the required periodic deposit. Okay, common examples: retirement savings, college funds, savings for a house, okay. Then let's see the formula for sinking funds. R equals I times the future value 1 plus I to the power n minus 1, where R is the deposit payment or deposit per period. Again, the future value, the desired future amount, I, interest rate per period, as same as the amortization, I equals R over M. Also, N, the total number of deposits. Therefore, N equals again M times T. Okay, the first thing, before moving towards the examples, let's see how to distinguish the two problems. How to distinguish the sinking funds and amortizations. Okay, how to distinguish the two problems. Okay, how? First, ask yourself what is happening to the money. The important thing is ask yourself what is happening to the money. Okay, then within the amortization, money is borrowed today and payments reduce the amount you borrowed. Use the present value and the balance move towards zero. Those are the things you can identify that the question or the amount says the amortization. Amortization, money is borrowed today Also, payments reduce the amount, the loan amount. Use present value. The balance moves towards zero. Okay, what about the sinking funds? The sinking funds, deposits are made over time. The account grows towards a future goal, use future value, and the balance moves upward. Sinking funds. The first thing, deposits are made. Over time, the account grows towards a future goal. And use future value. Also, the balance moves upward. Okay, then let's move forward to the example. Example, it says, Andrea wants to accumulate 250,000 for retirement. Andrea wants to accumulate 250,000 for retirement. Okay, she will make monthly deposits for 25 years. Make monthly deposits for 25 years. Then the account earns 7.2% per year compounded monthly. 7.2% per year compounded monthly. Right? Find the required monthly deposit. Okay. Then first thing, identify the problem is amortization or sinking fund. Here we have deposits are made over time with the future goal. So she wants to accumulate $250,000 for retirement account in future. So sink in funds. Then step 1, identify the future value. Identify the values. Okay, let's say future value $250,000 and the periodic interest rate I R over M 0.072 over M monthly 12 0.006 and the number of deposits M times T 12 times over how many? 25 years. Therefore, 300 equal number of deposits. Then step 2, substitute. R equals I times future value over 1 plus I to the power n minus 1. Then let's substitute those calculated values. R I equals 0.006, future value $25,000, 250,000, and 1 plus 0.006 to the power n 300 minus 1. Okay, use your calculator to calculate the numerator first. The numerator 1500 and the denominator 1.006 to the power 300 minus 1. Then using calculator you can get the value. The monthly payment, Andrea should deposit approximately $298.97 at the end of every month. Andrea should deposit approximately $298.97 at the end of every month to achieve her goal, $250,000 in her retirement after 25 years. Okay, let's see the interpretation again. So, how much will Andrea personally deposit over 25 years? How much will Andrea personally deposit over 25 years? So 300 times how much per month? There are 300 months. Each month $298.97. 89,691. Right, correct. Please make sure to calculate using your calculator. Yes. Then her account reaches 250,000 because the remaining amount comes from compound interest. So this example shows how beginning early can make a major difference. Correct? Because her account reaches $250,000. After 25 years, each month $298.97 she deposit over 25 years compounded monthly. So her account reaches 250,000 because the remaining amount comes from compound interest. The special thing here, not that this example shows why beginning early can make a major difference. Right? Okay, I will give you one more exercise here. Exercise. Emma wants to save $100,000 for her child's college education in 20 years. Emma wants to save 100,000 for her child's college education in 20 years. She will make monthly deposits into an account. Monthly deposits 6% per year, compounded monthly. Find the required monthly deposit. Okay, pause the video and try it by yourself. First, identify the values. Okay. I will end it up with the additional practice questions. Please make sure to practice. First one, decide which formula should be used. First one, a person borrows 20,000 and repays it through monthly payments. Second, a person wants to save $20,000 by making monthly deposits. Third, a family wants to determine the monthly mortgage payments. Fourth, a company wants to accumulate money to replace equipment in 5 years. Okay, so additional practice problem number 2. A student borrows 18,000 at 5.4% interest rate, compounded monthly, and repays the loan over 6 years. Find the monthly payment. Take your time and find out the value. Exercise number 3, self-exercise. A business wants to accumulate $80,000 in 10 years. The account earns 4.8% compounded monthly. Find the required monthly deposit. Okay, let's discuss the most common mistakes that the student can make. So, the students can make the mistakes with confusing present value with future value. Also, use the amortization formula for a savings problem. Use the sinking funds formula for the loan problems, the major mistakes, and forgetting to convert the annual percentage rate into decimal form. Forgetting to divide the annual rate by the number of periods per year, using the number of years of n instead of the total number of payments, and round into nearly. So keep several decimal places during the calculation and round only the final payment to the nearest cent. Okay, I would happy to give you the calculator guidance for this also. Let's quickly go through the calculator guidance. For amortization, first calculate 1 plus I. Raise it to the power negative n. Subtract the results from 1. Fourth, calculate I times the present value. Fifth, divide the numerator by the denominator. Okay, next. For sinking funds, First step, calculate 1 plus I as same as the amortization. Raise it to the power n, not the negative n. Subtract 1. Calculate, fourth step, calculate I times future value. Finally, divide the numerator by the denominator. Okay, then let's summarize today's lesson. Today we studied two applications of annuities. The loan amortization problems, a present debt is repaid through equal periodic payments. In a sinking fund problems, equal periodic deposits are made to reach a future savings goal. For both types of problems, we must carefully identify the periodic interest rate I, the number of payments or deposit N, and whether the known values is a present value or a future value. Remember that loan today, payments later, amortization, savings goal later, deposits now, sinking funds. Thank you for watching and I'll see you in the next lecture.